Hello! Today we continue solving problems, but the next block of the lesson will be devoted to problems that we will solve using solutions. What are solutions? Recall that a solution can be thought of as a mixture. And solutions can be by themselves, they can be liquid, they can be gaseous, they can be solid. The liquid solution is seawater, the gaseous solution is air, and the solid solution is sand. It is a solid solution. But most of the time, the problems that are solved, they involve liquid solutions because this situation is the most common. In order to understand how to solve such problems, one must have an idea of what the solution itself is. Let's say a particular solution. For example, if we take seawater as a solution, and that's the kind of water you're familiar with, you've seen it many times. This solution, by the way, will be homogeneous. You can't see where the salt is, let's say, and where the water is, then this solution is homogeneous. It's not always going to be exactly like that. That is homogeneous. Heterogeneous solutions are respectively homogeneous and heterogeneous. So what does a solution consist of? A solution is made up of a substance which is called soluble, and such a substance is dissolved in another substance of some kind. Generally, a dissolved substance is a substance that is in a smaller amount than the substance that is the solvent. For example, if we take the example of seawater, the dissolved substance in this case is salt, and in this case table salt, sodium chlorine, sodium chloride. And if it were to be, for example, another solution, a solution that contains another salt or acid or alkali, then in that case the dissolved substance would be these substances. And what that substance is dissolved in is called a solvent. And the solvent can be a variety of different substances. The most common, of course, is water. But water is not the only solvent. It can be, for example, ethyl alcohol, C2H5OH, and others. That is, solvents come in a wide variety of forms, but by far the most used solvent is water. Water is the most common solvent, and therefore aqueous solutions are the most common of all available. So when we talk about solutions, it's important to understand both what a solution is, what it's made up of, and how you express the content of the substance, the dissolved substance in the solution. There is the concept of concentration. Concentration is a concept that can be applied in a variety of in many different ways. For example, it's very common to use concentration, and I'll make it short, which is measured in grams in relation to volume. And in this case, as we've done before, I'd like to show you a triangular formula that can be used to find this concentration. So then in this case, at the top we have the mass of the substance that's soluble, and that's expressed in grams. For example, 10 grams of salt, and it's related to the volume. And volume in this case is measured in decimeters of cubic meters. And the ratio of mass to volume and is called concentration, which is expressed in grams referred to decimeters. Cubic meters, that's the formula. So in this case, to find the concentration, you need to divide the mass by the volume. Let's specify right away, and if the volume will not be given in decimeters cubic, but for example is in centimeters cubic or in some other units, please do not forget that the volume in this case should be translated strictly into decimeters cubic, because this is how it is customary to express this concentration. Now the second kind of concentration is the concentration which is expressed in terms of the ratio you get by moles, and decimeters cubic. So let's express it again also as a formula, a triangular formula. So we'll have a number at the top, mole. And in this case, it's measured in moles. And at the bottom, we have the concentration expressed in moles. And decimeter is still the same in cubic degree, and down here we have volume. We measure the volume in this case still in decimeters, which is to the third degree. Notice there's a difference between the concentration that I showed before and now, because in this case it's the mole number ratio that's taken from the top. Well, but if it is not given in moles, but the mass, for example, of a given dissolved substance, then the mass must necessarily be converted into moles, because you cannot then use this formula if any of the quantities are not in these units. It's the same with respect to volume. And finally, the third kind of concentration that I would like to say is concentration, which is applied more in school. And this quantity is applied very widely in problems, for example, when it is solved for the preparation of solutions. But in universities, this value is not so often applied. Although I could say that in our environment, solutions that mention concentration expressed in so-called mass fractions, it's used very widely, especially by pharmacists, because the preparation of solutions goes mainly using this concentration. So this would be the concentration which is expressed in what's called mass fraction expressed as a percentage. And then we'll express, let's do the same with the triangular formula at the top. Then we have the mass of our substance, which is the dissolved substance. And it's usually expressed in grams. And at the bottom, we have the concentration expressed as a percentage of the mass. And at the bottom, we'll have the mass of the substance, which is the solution, which is the result of our mixture, which is used as a total part. That is, the concentration is expressed in mass fractions. It is a part of the whole, but it is expressed strictly in percentages. Or if we are talking about concentration expressed in mass fraction, I would like to add, sometimes it is denoted by a special letter, mass fraction omega, and it is expressed in this case as a percentage, and this record is also used. And I would also like to say that when we talk about concentrations, and in particular including the molar concentration, you can see in some kinds of literature, for example, about molar concentration, an entry that is denoted by a big letter M, and then, for example, a 2-molar solution or a 3-molar solution, means that in this case, in this solution, there are 3 moles of dissolved substance in the volume of our solution. There are different types of concentrations. The ones I have shown today are part of such concentrations. There are others, but they are used already in narrow areas that are in chemistry, for example, in analytical chemistry. We will also learn to solve such problems with you in time, and already in the next lessons we will show the applicability of these formulas to solve problems. Check out our next lessons. Goodbye.